Hello and welcome everybody. I hope you all are fine. So I welcome you here in this lecture. This is lecture number 3rd. So let's begin this class without wasting our time. So guys, here we are. Here we will study hypermetropia, which is another defect in vision. In the previous slide we discussed, or in the previous lecture we discussed about myopia, and myopia was short sightedness. Now, this hypermetropia is just opposite of myopia. Okay, this hypermetropia is just opposite of myopia, because in myopia what happens? In myopia, we cannot see the far objects. We cannot see the far objects, but we can see the nearer objects clearly. But in hypermetropia, what happens? The objects which are nearer to us cannot be seen, but we can see the objects which are at long distance clearly. Okay, so guys, you should be careful and you should keep this point in your mind that hypermetropia has another name, and that is long sightedness. Okay, while myopia has also another name, and that is nearsightedness. Nearsightedness. Okay, so lots of students get confused that nearsightedness means a person can't see the near objects. Okay, they just assume it because of this name. But guys, you should be careful at this point that a person having nearsightedness can see the nearer objects clearly. Can see the nearer objects clearly. Okay, but he cannot see four objects. But this is just different. It is a kind of impairment in the human eye that allows a person to see distant items clearly but not nearer objects. Okay, so the person having long sightedness can see the distant items, or you can say the farer objects, but can't see the nearer objects. So this is a very important point. You have to remember so that you will not be confused. Now guys, let's talk about that what are the causes of this hypermetropia. So it happens due to decrease in the power of eye lens. So guys, you know that if the power of eye lens decreased, then the focal length will increase, because we all know that the focal length and the power are inversely proportional to each other. This is the formula of the focal length and the power, and you can see that they are inversely proportional. And what is the meaning of inversely proportional? When power increases, the focal length decreases, and when the focal length increases, the power decreases. So what happens when a person is having hypermetropia? Then what will happen? The power of his eye lens will decrease. So if power decreases, then focal length will increases. Okay, so decrease in the power of eye lens, increase in focal length of eye lens. And the second point, or you can say the second cause, is shortening of eyeball. This is also another cause, shortening of eyeball. Let's suppose this is an eyeball of a normal eye. So a person having hypermetropia may have a small eyeball. Okay, smaller than this. So in the next slide, I will explain how these 2 points are the causes of hypermetropia. So you do not need to be confused here. Here you just need to remember that there are two causes of this hypermetropia. First one is decrease in the power of eye lens, and the second one is shortening of eyeball. Now, a hypermetropic eye has its least distance of distinct vision greater than 25 centimeter. So you know that a normal person has a near point of 25 centimeter. A normal person has what? Near point of 25 centimeter. It means that he can see the objects behind 25 centimeter, or you can say beyond 25 centimeter clearly. But guys, what happens if a person has hypermetropia? Then this near point will change. Let's suppose it will become 30 centimeter. So it means a person cannot see the object which is at 28 centimeter. Okay, why? Because he only will be able to see the objects which are beyond 30 centimeter. Okay, so I hope guys you might get clear all these points. Now let's move ahead and let's try to understand the other important information about this hypermetropia. So let's move ahead. So guys, here we will try to understand the correction of this hypermetropia. Okay, so basically in this first picture you can clearly see that this is an image of the image formation at retina by a normal eye. Normal eye. Okay, so this is your eye lens, this is an object, rays are going like this, and after the refraction it is meeting at retina and the image is formed at retina. This is your retina. Okay, now the second image is the image of a defected eye. So what is happening here? Let's suppose this is your object, the rays are going like this, and after the refraction these rays are not meeting at this retina, they are meeting behind the retina at this point. So image is formed here behind the retina. Let me write it here, behind the retina. So this is a defected eye. Defected eye. Okay, now guys, this is the third image, and here we have illustrated then how this effect is, or you can say this defect is corrected. So how can we do that? So we can do it by the help of the convex lens. How can we do it? We can correct this effect by the use of convex lens. Okay, so the convex lens is basically a converging lens. A converging lens. Now guys, you can see here the rays are diverge at this point. The rays are what? They are diverge at this point. So if we add a converging lens, or if we keep a converging lens before an eye lens, then what will happen? It will converge the rays and this will make its image at retina. This will make its image at retina. Okay guys, so this is how we correct this hypermetropia. So if you are not able to see it clearly, let me draw a diagram for you. So guys, let's suppose that this is your eyeball. Okay, let's suppose this is your eyeball and this is the eye lens. Let me draw it here. And what did I do? I basically place a converging lens, and that is our convex lens. Which lens is called converging lens? A convex lens is known as converging lens. Now let's suppose this is your object and rays are going like this, and after the refraction it is going like this, and they are meeting at this point R. They are meeting at this point R. So this is an hyperometric eye, and because of this convex lens, this defect of vision is getting corrected. So I hope guys the concept how we correct this defect has been clear to you. So you will have to keep two things in your mind, that when we talk about myopia, whenever we talk about myopia, then concave lens is used, and when we talk about hypermetropia, then convex lens is used. Convex lens is used. Okay. So I hope these things are clear to you. Now let's move ahead and let's talk about the other things related to this. Okay guys, so here we are. Here we will discuss an example which will clear your concept, and it will very helpful for you in your examinations as well. So a person cannot see object before 30 centimeter, suggest which lens should be used to see things clearly. So our first task is to find out that which type of defect does this person have. Okay, so basically this person can't see the object before 30 centimeter. Okay, let's suppose this is 30 centimeter. This is its person's eye. Okay, let's suppose this is its person's eye, and this person cannot see the object before 30 centimeter. So what is the normal point, or what is the near point of a normal person? So the near point of a normal person is 25 centimeter. Okay, behind 25 centimeter, or you can say the things behind 25 centimeter can be seen by a normal eye. But here the near point has changed to 30 centimeter. This person cannot see the things before 30 centimeter. It can see the things only behind 30 centimeter, or you can say beyond 30 centimeter. Okay, so it means this person is having hypermetropia, because it cannot see the things which are near to him. Okay, it can see the things which are far away but cannot see the things which are near to him. So how can we correct this defect of vision? So we know that hypermetropia, let me write it here for you, that hypermetropia is corrected by the use of convex lens. Okay, by the use of convex lens. But guys, let's suppose we don't know that which type of lens is used. Okay, so we will simply place a convex lens before this eye. Okay, so what will happen? Let's suppose we know by the lens formula. Let me write down the lens formula, that 1 by V minus 1 by U is equals to 1 by F. And we know that, let's suppose this is your principal axis. So if this lens makes its image at 30 centimeter, then definitely this image will be seen by this eye. Okay, let's suppose, let me again explain you, because it is a little bit difficult concept. So let me explain this again. Basically what happens, this person is having hypermetropia, so he cannot see the objects at 25 centimeter. Okay, he can only see the objects which is at 30 centimeter. So how can we correct this vision? We can correct this vision by forming its image at 30 centimeter. Okay, let's suppose there is an object which is placed at 25 centimeter. So this will not be seen by this eye because this is hypermetropic eye. But if its image is shown at 30 centimeter, then this image will be seen by this eye. Okay, because it can see the object which is at 30 centimeter. So what will I do? We will simply apply this lens formula and we will try to find out what will be the focal length of this lens. Okay, so where we want to image be formed, we want the image be formed at 30 centimeter. So because this is at the left side of this lens, then I will write minus 30. Now what would be the object distance? Object distance would be 25 centimeter. Okay, and because this is also at left side, so I will again keep a negative sign. Now guys, when I keep these values in this formula, then minus 1 upon 30 and this minus will give plus 1 upon 25 is equals to 1 by f. When I take LCM, this will give me 150 and this will cancel out by 5 times and this will cancel out by 6 times. So finally, if I solve this, then I will get the value of 150 centimeter. Okay, and this 150 is positive. So what does it mean? It basically means that the focal length of this lens is positive. And which type of lens has positive focal length? So the convex lens has positive focal length. Positive focal length. Okay, I hope guys you got this point, that convex lens has positive focal length. So this is giving us idea that the lens which we use to correct this hypermetropic eye is known as convex lens. Okay, so I hope this thing is clear to you. Now one thing is to be calculated and that is power. And how can we calculate power? We know this is the formula of calculating power, where this f should be in meter. It should be in meter. So here f is given in centimeter. So first of all I will have to convert it in meter. And how can I do that? I will simply divide it by 100. So this will give me 15 meter. So what will be the value of power? 1 upon 15. So this is the, you can say, the power of this converging lens, or you can say this is the power of this convex lens. And I will also have to add diopter. Okay, because 1 by 15 doesn't have any meaning. I will have to add diopter. So I hope guys these things are clear to you. Now let's move ahead and let's talk about the other concepts. So guys, here we are. Here we will try to see other defect of vision, and that is presbyopia. So what is a presbyopia? It is very important. So it is a kind of defect in the human eye caused by aging. So what is the cause of this defect? The cause of this defect is aging. Okay, it happens due to the following reasons. The first reason is decrease in flexibility of eye lens. So basically what happens guys, whenever a person gets old, then the flexibility of eye lens automatically decreases. Okay, this is we call aging. So why does it happen? This is because aging. Now what is the flexibility? So flexibility you can understand is as a power of accommodation. It means this lens cannot be adjusted. it has become a little bit rigid. So that's why it cannot, focus the light at retina. Now guys, let's talk about the second cause, and that is gradual weakening of ciliary muscles. So it can also be a cause. When ciliary muscles gets weak, then the flexibility of eye lens may be affected. In this, a person may suffer from both myopia and hypermetropia. So basically guys, what happens when a person has presbyopia, then this person can have both the effects, myopia as well as hypermetropia. It means he cannot see the objects which are far from him. Let me write, which are far from him, for objects, and he cannot also see the objects which are near to him, or you can say nearer objects. So guys, this type of vision is known as presbyopia. Now guys, let's talk about how this presbyopia can be corrected. So let's move on to the next slide, and let's talk about the correction of this presbyopia. So by employing a bifocal lens of sufficient strength, we can correct this effect. So what happens guys, in this image you can see that in the upper side of this lens we used a concave lens. Here we have used a concave lens, and here we use a convex lens. Here we use a convex lens. Okay, so this concave lens will correct, what will it correct? It will correct myopia. And this convex lens will correct the hypermetropia. Okay, so this concave lens will make it see the objects which are far from it. Okay, and this hypermetropia can be corrected by this convex lens, and this convex lens will make it see the objects which are nearer to it. Okay, so I hope guys these things are clear to you. This convex lens is used to correct hypermetropia, and it will make it see the nearer objects, and this myopia is corrected by the concave lens, and this will make it see the objects which are far from it. Okay, so this is the correction of presbyopia, and the lens which we use to correct presbyopia is known as bifocal length. Because guys, you can see this is made up of two types of lens. Convex lens will also be there, and concave lens will also be there. Why we use convex lens? For reading, okay, or for making it able to see the things which are near to it. Okay, it can help a person to read newspaper, but this concave lens is used to see the objects which are far from it. Let's suppose a student is sitting at the last bench and something is written on the blackboard. He is not able to see what is written there. So by this lens, by the concave lens, he can see that the word or whatever is written on that blackboard. So I hope guys these defects are clear to you. So now let's move ahead, and I hope guys whatever I have taught you, you might have been able to understand. So thank you so much guys. I am ending this lecture here, and see you in later lectures. Bye bye.